Welcome to Algebra 2, Semester 2, Unit 12, Section 7.4. Okay, we are moving into logarithms. Many of you will feel so smart when you do these because logarithms is something that's kind of difficult to explain to others, and so a lot of people sit out there and kind of go, what is going on? So, first question that we want to ask, what is a logarithm? Okay, well, to do this, I'm going to take you to a graph. Let's go over here and graph something just for a minute. I think this will make the most sense on what a logarithm is. Let's say that we have our xy axis. Okay, and let's say that I have you graph, y equals 2 to the x. So if we just make our table of values, and you can just watch this for a minute. If we have a negative 2, 2 to the negative second is 1 over 2 squared, which is 1/4. 2 to the negative first would be 1 over 2 to the first, which is 1/2. 2 to the 0th is equal to 1. And 2 to the first is equal to 2. 2 to the second is equal to 4. So when we graph that, we come over to negative 2, and it's going to be at 1/4. At negative 1, it's at 1/2. At 0, it's 1. At 1, it's 2. And at 2, it's 4. And I know that you knew what that graph would look like because you've dealt with this graph before. This is our exponential function graph. So now, in explaining a log, what I want you to do is from chapter 11, please put in our y equals x. Oh man, I'm so sorry, I'm having trouble drawing a line this morning. Our y equals x inverse line. This is our y equals x. Sorry, my highlighter is not really functioning that well either. So we're going to do an inverse of this function. And actually the inverse of this exponential function is what we call a log. Okay? So it's the inverse of an exponential. So we take our y and our x. We have y equals x here. Remember, as we come across that, we actually flip them around. But you might say, wow, how do we do this? X equals 2 to the y. Okay? And we know that we absolutely flip this when we have a quarter for x. It is negative 2 for y. Let's plug that in there. 2 to the negative second would be equal to 1/4. Okay? 1/2 is equal to 2 to the negative first. 1 is equal to 2 to the 0th. 2 is equal to 2 to the first, and 4 is equal to 2 to the second. So we're going in reverse. And as you know from inverses, what happens is it comes perpendicular to this diagonal and the same distance. So we would have a point here, we would have a point here, we would have a point here, and we would have a point here and a point here. So this is our logarithm. Okay, now to show you the equation of this, this would be y equals 2 to the x, and this other one would be log base 2 let me think this through, y equals x. Okay? So that kind of gives you an idea of what the inverse of a exponent is. So this first thing that we look at, a log b y equals x, if and only b to the x is y. Now, one way that I remember these is that this number down here we call the base of a log. That number is the base of your exponent. Your answer to the log is there, and your y value is there. So let me make sure that I just did that other correctly. So yep, I just did it correctly. Good. Okay. So it's a little bit easier when we put numbers in there. Basically, when you see log 2, base 2, 8, you're saying 2 to what exponent equals 8? And the answer would be 3, because 2 to the third equals 8. Okay? So, let's get back to our notes. What you should fill in here is 2 to the third equals 8. And that is how we get the log answer. Log 2, 8 is 3. So I come down here and I write the exponential expression that I'm thinking. The base is 2, so my base is 2. Here's my exponent, 3 equals 8. Next one, the base is 4, so my base of my exponent is 4. Here's my exponent, 0 is 1. All of these should come out true because I've given you true log statements. So the base of 12 to the first is 12. Base of 1/4 to the negative first is 4. Okay? Base of 3 to the fourth is 81. Base of 7 to the first is 7. Base of 14 to the 0 is 1. Pause the video and you do this last one. Should be 1/2 to the negative fifth equals 32. Please feel free to pause the video anytime as you go this morning. These really take some time to think through. You have to look at the question and then reverse it in your brain, and I'm going to write down that reversal so that you can see what I'm thinking. So, two basic values that we need to remember is that log b to the first equals 0 because any number to the 0th power is equal to 1. So that's any number. Log of any number. B is any number. If it equals 0, then it's to the 1. Or, yeah, that's the easiest way to put it, because it's to the 0th power that it's equaling 1. Okay, the next thing is that any number, here's our base, any number to the first power equals itself. That's what that's saying. Okay? Any number to the first power is equal to itself. Okay? Next page, the common log and natural log, printed on the wrong page there. And I don't know that I'm going to get it corrected. So please write it up here. Common log is log 10x which is also just written as log x. And this is the one that we type into the calculator. Okay? A natural log log to that natural e to the x, we just write that as ln x. ln x, and you'll see it in the calculator as well. Okay? So now let's solve some logarithms. Again, write these out here what you're thinking. 4 to what power equals 64? Well, 4 times 4 is 16. 16 times 4 is 64, so we know it's to the third power. Okay? Now we say 5 to what power is 0.2? Well, that's a stumper, because we might go, we don't know of anything. Realize though, 0.2 is 2/10, which reduces to 1/5. If we have the 5 on the bottom, we know that it's a negative exponent, so it's -1.
It is Monday, April 20th. The time
1/5
is 7:35
to the x
Attention, please.
equals
ICDA
125. 1/5 to what power equals 125? Well, I know 5 to the third. 5 to the third is equal to 125. So 1/5 would be to the -3rd. 36 to what power equals 6? Well, we know that 6, the square root of 36, equals 6. So from our previous lessons, square root, we know can be written as 36 to the 1/2. So 1/2 is our answer. Next one, 2 to what power equals 32? Can multiply that out, that would be 5. Please pause the video at this point and try to fill these in. 3 to what power equals 27? That would be the third power. Now this is a natural log, so we're saying 10 to what power equals 12? You would actually plug that into the calculator. You'll see a log button. You just hit log 12, and we get an approximate. Change that equals to an approximate 1.079. Please do that in the calculator when you come to class. And this one you're going to type into the calculator too. I want to make sure that you actually do those two in class. Okay? So, if we have log b to the x equals x, basically what we find is that log 2, this is just an example, log 2, 32, is equal to 5, and that these cancel because 32 is the same thing as 2 to the 5th. So if we have log 2, 2 to the 5th, then we know that it's equal to 5. Okay? Next one. So on that last one, basically we learned that we can cancel those two. On this one, we're going to see we can cancel these two. Because an example would be 5 log 5th to the 25. Well, we know that log 5th to the 25th equals 2. So log 5 to the 2nd equals 25. So see how we get the 25 there and there? We can just simply cancel those out and we have our answer. So let's go down and do these few real fast. 10 to the log 10, we can see equals 4. 8 to the log 8 equals x. Log 7 to the 7 equals negative 3x. And log 2 to the 64, ooh, we have to change that 64 into an exponent of 2. So log 2 to the 2 to the 6th x. Now we can cancel our log 2 and our base 2. and we get 6x. Okay, thank you very much. That ends this session. I'll see you tomorrow in class.